Section 2.3, Solving Linear Inequalities. So this is going to be different than an equation. An equation with linear equations had one answer. With solving linear inequalities, we're going to have lots of answers. So we're going to need to know how to shade, write with interval notation, and something called set builder notation, which we'll get to in a little bit. First of all, let's figure out what are the symbols with inequalities. The first one is your less than symbol. So the number has to be strictly less than the number listed. Greater than symbol is the one below it, again has to be strictly greater than. On the other side we have the less than or equal to. So we could equal that number or we have to be less than that number. And the one below it is the greater than or equal to. Again, it has to be greater than that number listed or it could be equal to that number. So those are the inequality symbols we'll be using for this section. To solve linear inequalities, the first thing we want to do is remove parentheses. And how do we do that? By the distributive law. Number 2, combine like terms that are on the same side of the equal sign. So if there's any like terms we need to combine that are on the same side, go ahead and put them together. Then we'll get the variable on one side, and we're going to take numbers to the other side of the equal sign. So again, just get variables on one side, numbers on the other. Isolate the variable. Lastly, divide if necessary to get the variable having a coefficient of 1. That's how we get the variable by itself having a coefficient of 1. There's a caution: when multiplying or dividing by a negative, always flip the inequality. So make sure you understand when you're dividing by a negative, you're actually flipping the numbers that are on the right side of the inequality or on the number line to the left side, or vice versa, from the left side to the right side. So when those numbers get flipped, the order flips. So therefore the inequality has to flip as well. So we're going to learn how to solve, graph, write in set builder notation, and write in interval notation. Number 1, x plus 6 is greater than or equal to -1. To solve it, following those steps listed above, we're going to need to get rid of parentheses where there are none. Then we're going to want to combine like terms that are on the same side. There's no like terms on the same side. Then we're going to get variables on one side and numbers on the other, so we'll need to subtract 6 on both sides. So we get x being greater than or equal to -7. Since x already has a coefficient of 1, we have solved our inequality. The next thing is to graph. So when we graph, make sure you understand that zeros in the middle, 1, 2 positives are to the right, and negatives are to the left. So show me that you have some of those numbers listed. Let's go down to -7. And this inequality states that all numbers have to be greater than or equal to -7. Greater than -7 is -6, -5, everything to the right. So you see how this is kind of pointing to the right? If the variable's on the left-hand side, you can kind of take into consideration how that arrow, in a sense, is pointing. So everything that's greater than -7 is to the right. Now, what should we put on the -7? Some of y'all are used to open circles and closed circles. We're going to try and move away from that and have parentheses and brackets. So when do we use parentheses? You would use a parentheses when you would use an open circle, when you do not include the starting point. You would use a closed circle or bracket when you do want to include that point. So because we have the equal sign underneath, we do want to include -7. So we're going to need to put a bracket on the -7. So we have solved it and we have graphed it. Now let's talk about set builder notation. I'm going to abbreviate set builder notation as SBN. Set builder notation has to start off with the set marks. If you've never seen the set marks, they're like little birds is what I call them. So with the set notation, you want to use a variable that you've been dealing with, which is x. So you put an x in the first spot. You draw a line down, but that line down means such that. That represents the words such that. And then all you have to do is put what you've solved into the next space. So x has to be greater than or equal to -7. The way you read that is the set of all x's such that x has to be greater than or equal to -7. It's just another way to represent what you have found as your answers. The next way we need to be able to show is with interval notation. So with interval notation, I'll express that as IN for interval notation. This says look at the graph and show me what you shaded from left to right. Well, from the left we have negative infinity, and on the right we have positive infinity. So from left to right we started at -7 and we shaded everything that direction. So interval notation is going to have a bracket with the -7, comma, all the way to positive infinity, and you're going to use a parentheses. We never can include infinity, so we're going to use a parentheses on infinity every single time. Now what we'll do is number 2. 5 plus 3a is less than -10. Following the steps on the previous page, we'll start off by subtracting 5 on both sides. So we get 3a is less than -15. We'll still need to get a by itself, so we'll divide both sides by 3. The inequality does not flip. You're not dividing by a -3. You're just dividing by a +3. And -15 divided by 3 is -5. So do not flip the inequality on that problem. So again, we're going to need to put our 0 on the number line. So here's our 0. Here's a +1 and a 2. Here's a -1. We'll go down to -5. At this point, we have to see what this inequality states. It's all the numbers that are less than -5. Less than -5 is -6, -7, -8, and so forth. So we'll need a shade to the left. Because we don't have an equal sign under the inequality, we will use a parentheses to show that we don't include the -5. We include everything past it, but not the -5. So now what we need to do is write set builder notation. So we'll do SBN for set builder notation. Again, we'll start off with the squigglies, and we say what variable we used, which was a. So it's a set of all a's such that, and then whatever we solved goes in the next spot. A is less than -5, and then we close our set. So this states the set of all a's, or all numbers, such that the number has to be less than -5. Lastly, we'll need to do interval notation, so I'll abbreviate that as IN for interval notation, and we need to show from left to right what we've shaded. Well, left is from -infinity, right has positive infinity. We are shading towards -infinity. So we'll need to start with -infinity, again use a parentheses, we do not include infinities, all the way to -5 with a parentheses again because we're not including the -5 as well. So next let's go to number 3. Negative parentheses x plus 2, close the parentheses, minus 5x is less than or equal to 3x plus 7. So this is going to require a few more steps. First step is to get rid of parentheses, so we'll distribute the negative. So we get -x minus 2. We still have a minus 5x is less than or equal to 3x plus 7. We'll then combine like terms that are on the same side. So those are like terms. Putting those together gives me a -6x minus 2 is less than or equal to 3x plus 7. We'll then get variables on one side and numbers on the other. So we'll subtract the 3x over to the left, which means we'll add 2 over to the right, giving me -9x is less than or equal to +9. At that point, we need to get x by itself. To do so, we're going to divide both sides by -9. This is when you're going to flip the inequality because you divided by a negative. So we're going to end up with x actually being greater than or equal to -1. Again, we flipped the inequality because we divided by a negative. So here is my number line with the 0. +1, +2 is to the right, and we're going to have -1, -2 to the left. Since x has to be greater than or equal to -1, what does that mean? All numbers that are greater than or equal to -1. So we'll have a bracket at -1, and we're going to shade to the right because of the fact we want all the numbers that are greater than that. So now we need to look at set builder notation, SBN. So set builder notation, start off with the set marks. So a set builder notation, it's a set of all numbers x such that, what did we find? We found that x had to be greater than or equal to -1. Now at that point, we'll do interval notation, IN for interval notation. IN says start from the left and go to the right and show me what you've shaded. I didn't shade anything towards -infinity. I started at -1 and I went all the way to +infinity. Again, do not include infinity, so we're going to have a parentheses. Number 4. 1/7 parentheses 3x minus 28 is greater than negative 4/7 x plus 1/4. We really should love multiplying fractions, and the reason why is because all you have to do is multiply straight across. So 1 times 3x is 3x, and 7 times 1 is 7. Minus 1 times 28 is 28, all over 7 times 1 is 7. It's supposed to be greater than negative 4/7 x plus 1/4. At this point, we'll need to get variables on one side and numbers on the other. So we'll add 4/7 x over to this side. As you can see, we have common denominator. We also know what that number is, so that's going to make it nice. 3x over 7 plus 4x over 7 is 7 over 7, which turns out to be x. Minus 28 divided by 7 is just 4, is greater than, and the only thing we have left on the right-hand side is 1/4. You could have multiplied by an LCD to get rid of all your fractions, but you don't need to. Adding over the 4 to the other side, we're going to add 4 to a 4th. When we do so, we just get x is greater than 4 and 1/4. So at that point, we'll go down to our number line. Here's 0, here's 1. Now 4 and a 4th is in between 4 and 5. And it's closer to 4, so just make a little dot that it's closer to 4. And we want to know all the numbers that are greater than 4 and 1/4. So greater than is to the right, so we're going to say all those numbers this direction. And then because there's not an equal sign, we're still going to use a parentheses to show that we do not include the 4 and 1/4. At this point, let's talk about set builder notation. So for SBN, it's a set of all. What letter are we using? X. Draw your line down. That means such that x had to be greater than 4 and 1/4. Now, if we want to talk about interval notation, again, we need to go from negative infinity to positive infinity, and let's see what we shaded. So for interval notation, we started at 4 and 1/4, again with a parentheses, and we went all the way to infinity with a parentheses as well, because we never can include infinity.